Okay, so here I have the start of video 2 for this lesson, and we are going to kind of shift gears to classifying numbers, different types of numbers. So we can classify numbers by their characteristics, just like we can classify pretty much anything by its characteristics. Some types of numbers can be represented on the number line, just a number line with integers on it. And then we can classify numbers using sets. So a set is a grouping of well-defined objects or a collection of objects. So a grouping of animals would be cats and dogs. And then inside of that set, maybe an element of that set is a certain type of dog. Okay? So when we talk about sets, each object in a set is the element, one object in that set. A subset is elements from the given set. So a subset, let's say a subset of the dogs would be golden retrievers. Your dog Sparky would be an element of that set. Okay? So a set is a well-defined collection of objects. A subset is just a smaller set inside of a set. So a little bit more specific. So you're going to see this notation. We're going to list the elements of sets using those braces. Okay? So a few definitions. First one's a rational number. Rational number is any number we can write as a fraction in that form a over b, where a and b are integers and b is not 0. Okay? A rational number in decimal form either terminates, means it ends, or it repeats, like 4.1666 going on forever, or 0.3333, that's 1/3. So each group on this little diagram here shows a subset of the rational numbers. So one set is the natural numbers. Those are positive whole numbers, not including 0. Not including 0. We call those the counting numbers, 1, 2, 3, 4. Whole numbers. Whole numbers are positive whole numbers, including 0. So positive whole numbers include 0. Okay? So we could say the natural numbers are a subset of the whole numbers, because the whole numbers contain the natural numbers plus a little extra. Going a little bit bigger, integers are positive and negative whole numbers, including 0. So integers, we're getting a little bit broader here, okay? So integers are positive and negative whole numbers, not including 0. And then next, an irrational number is a number that can't be represented by a fraction of 2 integers. And in decimal form, these decimals do not repeat and they do not terminate. So a couple examples is one like 0.10100100001. That doesn't, it has a pattern, but it does not repeat. Okay? So patterns are different from repeating. And pi is an example of another irrational number. Another example of an irrational number is any square root that's not a perfect square. Square root of 2 is irrational. Square root of 17 is irrational. So square roots of non-perfect squares are irrational numbers. Okay? So that right here. If a whole number isn't a perfect square, its square root's irrational. Rational and irrational numbers all are under the umbrella of the set of real numbers. We are going to 99% deal with real numbers when we talk about anything in this class. Okay? So just some examples of square roots, rational versus irrational. Perfect squares, rational. Not perfect squares, irrational. Okay? So I'm going to move ahead for some examples of that, how to classify them. So we're going to list a few of these sets. So what I'm going to do is I'm going to think about 15. 15 is a whole number, right? And it's a positive whole number. So 15 fits in the set of the natural numbers, whole numbers, integers, that should be an R, integers. It's also a rational number, and it's also a real number. Now, I guess I don't have to include real number. We're establishing that it's part of the real numbers. So that's all the sets it belongs to. Natural, whole, integer, rational. It fits all those characteristics. So it fits into each of those. So rational is the biggest group, contains the most numbers. Well, it doesn't contain the most numbers, but it contains the widest variety of numbers, I would say. And then integers gets a little more specific, whole numbers more specific, natural numbers even more specific. Okay? So in part B, this one's a little bit more simple. This one, it's not a whole number, so it can't be a natural or a whole number. It's negative, but it's not a negative whole number, so it's not an integer, but it's a decimal that ends. So this would be considered a rational, I'll fix that, a rational number. This is a rational number, okay? And then C, if you're not sure if this is a perfect square, it's fine if you use a calculator to double check. That's fine. 57 is about 7.5498, and it's just going to keep extending without end, and it doesn't repeat, it doesn't end. So this would be considered irrational. All right? So, moving ahead to the got it. Okay? Sorry. I'll just quick. This is not a decimal that repeats or ends. So that's why it's irrational. So with the got it, take a minute, work through them. I'll show you my solutions in a few seconds, and then you guys can kind of see my explanation of those solutions. Okay, so for the got it, this is really similar to the examples we looked at above. So what I did was I first just determined square root of 9 is 3. 3 is a positive whole number. It is natural, whole, integer, and rational. Okay? It fits all those categories. And if it does fit all those categories, I do want you to tell me all the categories it fits in. That's important. Next, 3/10 is rational. If you're not sure whether it's rational or not, turn it into a decimal. That is a decimal, is 0.3. 0.3 is a decimal that ends. That makes it rational. Part C, that negative 0.45, that's also rational. It's a decimal that terminates. It's a decimal that ends. So that's why that one's rational. And then lastly, square root of 12 is about 3.4641011615. That doesn't look like it's going to end or repeat. It's not a perfect square. That's why that's irrational. Okay? So you can take some basic steps to figure out whether numbers fit in those kind of sets or subsets of the real numbers. So again, this is a big lesson. So I'm going to have you guys move on to the next part of that lesson, the next activity, and then I'm going to have you complete the notes in a video towards the end. Okay?